If you've ever needed to generate a list in Python, you've likely considered either using a for loop or list comprehension. And depending on the situation, list comprehension can be the most readable and efficient option. But why though? Why is list comprehension more efficient than using a for loop when generating lists? To see the clear performance difference, I decided to run a test. On one hand, I have a function that takes in a variable n and creates a list of length n using a for loop. In each loop iteration, it just appends that item to the list, and at the end, it just returns it. On the other hand, I have a function that also takes in a variable n, but instead uses list comprehension to create the list of length n. Now, to compare the efficiency of these two functions, I generated a random number between 1000 and 12 million. Then I timed how long each of these functions would take to generate a list of that size. I then repeated that process 300 times and, well, here's the results. As you can see, list comprehension had a pretty clear advantage over using for loops. Now, I do want to point out that these were very simple operations. Depending on the operations being performed when creating the list, this advantage gap may vary. I also want to note that I ran this test using Python 3.11 with the official CPython implementation, so depending on the type and version of Python you're using, your results may vary. Now, before we dig into why we're seeing this advantage, I want to make sure we nail down one important concept first. That is, how Python runs on your machine. Now, this may be a shock to some of you, but Python is a very high-level programming language, meaning that it's made to be very easy to read and understand, but when you run your Python script, there are several steps involved before your code can actually run on the CPU. If you were to just hand your .py file over to your CPU, it would have no idea what it's looking at. Your code must first pass through an interpreter. Now, the interpreter essentially has three parts: the compiler, the bytecode, and the Python virtual machine. The compiler scans your .py file and simplifies its functionality into little instructions called bytecodes. These bytecodes then get sent to the Python virtual machine, which reads these bytecode instructions and performs the corresponding functionality in C, which is the much lower level programming language that then gets turned into machine code, which is what runs on the CPU. What we're interested in this video is looking at the bytecode. Now, looking at the bytecode for a Python script is actually quite simple to do. What we're going to do is import the dis module into our script, which stands for disassemble. This module comes built into Python, so there's no need to pip install anything. Then all we have to do is say dis.dis with the name of the function that we want to look at as the input. And so when we run this, you'll see that we get all these bytecode instructions associated with that function. Alright, so let's compare the bytecode instructions for both our for loop function and our list comprehension function. I want to draw your attention to the iterating portion of these instructions because that's where the main performance differences lie. Alright, so you'll see that they both start with for iter, which is where the iteration starts for both operations. Next, we have the store fast for each method. This is essentially just storing the next item in a variable x. Next, we have the load fast instruction for each operation, but you'll notice they're loading two separate things. In the for loop, it's loading the list, my list, but in list comprehension, it's just loading the current value of x. Alright, and now we get to where the main performance difference lies. The for loop has to call this load method to load the append method. For some Python versions, this load method bytecode may also be called load adder, but they're the same thing. Then it has to load the current value of x, run a precall, and then call the append method. Loading and calling a method like this can become computationally expensive when it's called repeatedly in a for loop like this. This is because the C code has to first understand that it's dealing with a list, then it has to go and find the append method for the list object, and then finally performs the operation. Realizing that generating a list is a frequently used operation, Python implemented list comprehension, which uses this special bytecode, list append. As the name implies, it appends items to a list. When this bytecode gets sent to the Python virtual machine, it immediately knows that it's inherently dealing with a list and it appends the item immediately, which eliminates many of the additional steps needed in the for loop to load and call the append method. So there you have it. List comprehension is using its very own specialized bytecode that is specifically designed for generating a list. Now, while list comprehension is generally more readable and more efficient, it really can depend on the situation. If you're generating a pretty straightforward, simple list, then list comprehension is the way to go, but it can be overused. If you start trying to use complex operations in your list comprehension and therefore sacrificing readability, it's probably a better idea just to use a for loop. I want to take a moment to thank the Bike Club members for the incredible support that you've shown. If you've enjoyed this video, be sure to leave a like, and subscribing is the best way to see more content like this. Thanks for watching, and I'll see you all in the next video.